Okay, welcome everyone. This is going to be CCNP Class 5. This is a redo because we're now recording in HD. This is going to be BGP Part 1, and it's going to be very simple. We're going to take it slow. And what we're concerned about in this lesson is getting BGP neighbors to come up. So you've got one side is your ISP, your service provider, and you've got your side, which is your network admin for a company, and you want to get BGP running between both sides. So some basic peering, and there's going to be two main tasks for that. And if we have time, we'll get into actually popping in some networks in there, but that's not the focus of this part one. The focus is just getting the two sides to be up and see each other. In class 6, the next class, we'll cover injecting networks, getting networks in there, the different ways of getting networks in there. And then class 7 will be getting BGP to route in weird different ways. So manipulating the path selection, which is messing with the weight and all the different attributes that we can play with in BGP. So we assume a couple things before we actually begin. We assume that your internal network is fine if you're running BGP as a company, because we're assuming that you are a decent network admin, so your OSPF is working, your EIGP is working, stuff like that. And in CCNP, there's a decent amount of BGP, but if you want to get more advanced, as you see in this handout right here, you can take two other exams if you want to go hardcore into BGP. So you can actually take the BGP exam. I'm not sure if it's still out there. It should be still out there. I took it for my CCIP exam. So maybe in the CCNP service provider, you might still see it. And of course, you could go for CCIE, which you will see just a whole bunch of BGP stuff. BGP is going to be very, very different from the other routing protocols you've messed with. The other ones, you could basically type in router OSPF1, network all zeros, area 0, and it will work. You'll find all your other neighbors. But in this one, BGP, you've got to be very anal in typing stuff out. You miss one letter, one number, and you're toast. So that's kind of the thing to worry about. Also, you're going to have to think big picture here. You're not concerned that much about routes in between two routers. That's kind of like the piddly stuff. You've got to think big now, exchanging information between networks and, of course, you and the internet. And if you mess up something on your end, the internet is going to see it. And then they'll talk about it on Nanog and a couple other places that they exchange info on. They'll be basically like, dude, whoever's the admin at this place, he really screwed up. Look what he did. And we've got another thing to worry about is, well, kind of one of the tenets of BGP is after the routes come into your network, how you deal with it is up to you. So once you fire up BGP, you start getting routes and prefixes from the internet. Well, now you've got the hot potato in your network. Now you could drop the hot potato, you could stop it, you could decide to route it, but really that's up to you. And conversely, the same thing kind of happens on the ISP side. They're running routes and networks and stuff like that. You can't really tell them that much how they should deal with that traffic. You can sort of try to influence, but a good service provider will basically slap you down and ignore all of that. Okay, on to task 0. Well, before we get to task 0, let's just look at our topology here. Assuming you have everything up, your GNS3 should be up and running. You should see green lights. This is just a picture, so that's why you see red dots everywhere. You've got your typical triangle in the center. We've got two routers hanging off the sides. And in this case right here, we're going to assume that everything R1 and R2, so kind of like that network right there, is going to be the service provider. And then everything past here is going to be your company. So everything circled with blue, your company, everything circled with red is the service provider. We're going to actually play both sides here. We're going to be pretending to be the service provider and the company. So just keep in mind who you are at that particular time. In class 6 and 7, what's going to happen is this. We're going to pretend that everything is blue is your company, and you're going to be peering up two different directions. So then that gives us lots of opportunities to go one way or the other way. Okay, so that's our basic topology. This is topology 11. You should just have IP addresses right there. No big deal here. Any questions before we begin with task 0? Okay, let's just go into our GNS3, go into router 3, and just ping everything 255, 255, 255, just to see if you have anything coming back. So you should have, let's see, 3 routers coming back, 13.1, 35.5, 34.4. And if you look at your topology on router 3, these correspond to router 1, the router 1 side of things, router 4's fast 00, and router 5's fast 00. And you did that ping from router 3. So if you don't have a ping, you probably don't have the correct IP address, or you don't have, maybe the interface is shut down. So easiest way to do that, show interface status, show IP NPR. Everything should be up. So one thing, let's do some housekeeping. On fast 00, that's your link towards the service provider. Just go on to interface fast 00, pop a description in there, capital letters, link to service provider. Or let's make something up. Cogent, Verizon, whatever link name you want to make up. And on interface fast 01, just say description, just do internal. And interface fast 10, description, internal. And now when you show IP int br, show interface status, nothing there, show interfaces description, there you go. Nice command, show interfaces description, shows you the full description and the status. If you don't really care about IP addresses, you just want the upstates and the description names in there. All right, so let's take a look at task 0. Let's see here, task 0. So before we set up BGP, we need to have our internal network configured correctly. So we're probably going to go with OSPF. Don't have to go with OSPF, but that's that's usually what we're going to be playing around with now and also in real life. And it's going to be pretty much dead simple. We just throw OSPF everywhere, and we probably want to do passive interface on the link towards the ISP. So this link towards the ISP, we're going to do passive. But everything else, we're just going to chuck in there. So what's that command we're going to use just to chuck everything into OSPF? Network all zeros, area, whoa, ran out of space there, area 0, right? And of course Cisco changes that second set of zeros all the way to 255, so not a big deal. So since we're going to be doing this on R3, R4, R5, R6, and R7, probably good to use Notepad or a text editor here. Let's use Kate since I'm running Mint. So you're going to throw in enable conft router OSPF1 network all zeros, area 0, end it out, show IP protocols. Okay, and now just paste that in there. And the reason I like doing that show IP protocols is just a quick verification that we have something typed in there. Show IP OSPF neighbor. Everything's two-way so far, but they're still talking. Show IP OSPF interfaces. And now we have our neighbors coming up because that 40-second mark just flew by. So we're good. Let's see, we need to do our passive interface because we don't want our ISP peering up with us for OSPF. That would be pretty bad. So let's see, let's do show interfaces description. So my link to Cogent is fast00. So router OSPF1. And passive interface that guy. So with that, if I look on R3, I should be able to ping all the way from R3. Let's see, the farthest we can go. Hopefully that 200.111 network is there. So if I can get to there, then I should be okay as far as my internal network. That's assuming I have 200.111 in there. Okay, so looks like I do. So we're good there. Any problems with getting OSPF to work on our internal network here? So all we've done is just put OSPF here.
How come I can ping across, but I'm not getting any neighbors on 3?
Okay, you can ping all the way to...
I can ping to 10.10.67.7.
Okay, you can ping here?
To R7.
Okay, so...
I can ping from 3 to R7.
That guy, that interface right there. R7's fast00.
Correct.
Okay, but you can't ping to 200.111?
I haven't tried that yet. I was just...
Okay.
Which one? 201 or
200,
Oh, 200. Okay. I can ping there too.
Yeah, so you're good.
But I don't see any But I'm not showing any neighbors.
Well, let's check. So on R3, show IP protocols.
Oh. OSPF1. Okay.
Show IP OSPF.
And I don't see anything in.
Show IP OSPF interface brief.
Everything's up.
Okay. But when you do show IP OSPF neighbor, you're not getting anything?
Correct.
Okay. Show IP route.
You know, I see a lot of ERGP. Why did I thought I got rid of ERGP?
Okay, so ERGP is probably getting you over.
All right,
That's okay.
Clear that up.
You just go no router EIGRP on every router and you'll be fine. So you went and you did OSPF on every router, right? But you still had
Yes.
EIGRP in there?
Yeah, I thought I took that out the
Yeah.
other day. I must not have saved it.
Okay, so just fix that and you should be okay.
You can continue.
Okay, so task 0, very, very easy. This is like sleepwalking here. No big deal, because we just want to get our internal network working. And another thing to check is, since you fired up OSPF everywhere, including this interface, R7 should be able to ping 10.10.13.3. So it should be able to ping all the way over to this side and come back. So just go ahead and verify that. Go over to R7, ping 10.10.13.3, and we have a success right there. Okay, let's take a look at task 0 again. Let's see, make sure, oh, we have another little thing in task 0. Make all traffic head towards router 3 by default. So we forgot one thing. Forgot a default information originate. So if we take a look at our OSPF network, which is there, and we want traffic to head this way, where are we going to pop that default information originate command on? Yeah, we're going to pop it on R3. And since we only have one way out, we'll be okay with having always there. So not going to matter one way or the other. Default information originate always. End out of there. Okay. And on this, since we only have one way of getting out, let's pop in a default route just to get us to the internet, so to our next hop. So 10, 10, 13, let's see where we're at, 10, 10, 13, 1. So we want to make a default route that goes from here to here, and then we'll just kind of chuck it out in that direction. So we're assuming that everything behind here is the internet, right? So once you get it to your ISP, your service provider, then the whole internet's going to know about it. So IP route all zeros, 10, 10, 13, 1. And just make sure you show IP route. And you should be able to ping 10, 10, 13, 1. That's your next hop. Then if you look over at R7, show IP route, you'll have a default route E2 coming from OSPF. Yep, it's right there at the bottom. So no big deal. Default information originate gives you that default route. So now all of your internal routers are going left if they don't know how to get to it automatically.
Can you explain those other the different options you have always and the default information originate?
Yeah, I can. Okay, so the question is explaining the different options with that default information originate. So what we did is on R3, I popped in a static route and I have default information originate always. And we'll see that on every router past there, if you show IP route, you'll see that you've got this default route that came in through OSPF. So that always command, if I go on R3 and I do this, if I kill that default route, you'll see that over here on R7, I will still have this default route in there. It's kind of like it's stuck there. So what I'm going to do here is I'm going to debug IP routing, and that will show me if any routing changes happen. Now let's see, if we go back to R3, show run pipe S OSPF. So that's my OSPF stuff, router OSPF1, network all zeros, default information originate always. So what I'm going to do here, actually I'm going to just completely nuke OSPF right here. No router OSPF1. Look over at R7 and you could see here that now that R3 is completely toast, I've lost that default route. I'm going to lose some others. So 10.10.13.0, all threes, and 3.0.0.0/8. So let's see if we understand what's happening there. So router 3 had a loopback here. That loopback was 3.3.3.3. Router 3 also had this in OSPF. So when router 3 dies, it sends that signal over. And then R7 goes up. Don't really need a route to that. Don't really need a route to that. And then you see that inside of that debug IP routing. So a signal came in, and then those routes are gone. So now what we're going to do is we're going to go back to R3, and we're going to take this one step at a time. We're going to do router OSPF1. Let's do network all zeros. Okay, we'll go back to R7. I'll hit enter a couple times so you can see stuff. And you can see the all threes comes back and the 10.10.13.0 comes back. So that means I turned on router 3, and now router 3 is telling me about that guy and that loop back. Now you may be wondering, well, router 3 is also connected to this guy and this guy, 10.10.35 and 10.10.34. Why didn't I get anything for those networks? Why do you think?
Sure.
Well, the reason is you already knew about them through R4 and R5, and they have the best ways of getting there. So R3, since it's farther away, there's no way that R3 can actually get you to these faster than R4 or R5, assuming that R4 and R5 are still up and running. So that's why when you go down here and you look at the output of the debug IP routing, we see the all threes, that's from the loopback, and 10.10.13.0, which is from that external link. Now if we go back here to R3, got to put in that fast passive interface in there. So that's not going to change anything, no big deal there. Then we add in default information originate. So now what we're going to do is we're going to do it without the word always in there. So no always word. And we've also taken out our static route. So you see here that we're waiting here. We're not seeing anything. And with OSPF, we definitely would have seen it by now. Gonna wait a couple more seconds, and so nothing there. We go back to R3, and let's see if I can find that default route. Okay, so that's my default route. Just gonna kill no in front of that. Hit enter. And now you see that as soon as I hit enter there, whoa, it's adding an all zeros route to there. So what happened is the static route, I made a static route pointing that way. OSPF sees that static route, pops it into my OSPF table, and then that's chucked out to all of my routers internally, and then it finally hits R7. So when you don't have the word always in there, you need that static route. And we could verify this, could validate this very easily. Just hit the up arrow, put a no in front of there. So I'm going to kill that default route, go over to R7, and you can see that default route's gone now, that from OSPF. All right, very, very easy to validate. Go back to R3. Now, I don't have the default route there. Go into router OSPF1, default information originate always, and then go back to R7. Now that default route is back. So you can see with that default information originate always, you're sticking that in there. Does that explain everything?
Yes, thank you.
Yeah, so always means it's always going to be there. If you take out the word always, then you just need to have the route in there. So we're just going to make sure that we have our route in there because we like connectivity. Connectivity is good. Okay, so I see a question from Chris. Could we have put a default gateway statement in R3 instead of a default route to get out to the internet? Well, let's see. Well, let's try it. I'm going to kill that guy. IP default gateway. Now let's see here. 10, 10, 13, 1. And I bet you when I show run, we may see something a little bit different.
Yeah, I just kind of want to know, right, what's your backup protocol? You know, what
Oh, okay, well, maybe not. IP default gateway 10, 10, 13, 1.
Okay, this guy didn't show up. All right,
Let's go over to R7.
prepped and ready to go.
Looks like we have a default route in there.
The point is what do you guys do to avoid
10, 10, 13, 1.
redispatch, I should say.
And that ping from R7, let's see, 10, 10, 13, 1. Oh, that's dying. Let's see if I can reach 10, 10, 13, 3. So that's my side, so I just can't reach the ISP side. So that default gateway command doesn't seem to work as far as this is concerned. So we could validate it. Watch this. Let's show IP route here. Okay, let's see.
Sure.
We've got that E2, but that's fine. That's probably because in OSPF, we've got that default information originate always in there. Yep, we sure do. Let's kill that. End out of there. Show run pipe S.
Oh, you still have
OSPF.
your older partners still have.
Okay, so we have default information originate, and okay, everything else looks good. Let's go back to R7, and you can see right there it's deleted that default route. So that gateway command is not liked by OSPF for that default information originate.
How, you know, because it's inevitable. It's gonna happen. You can't.
All right, makes sense. And you could play with it yourself. And it seems like tried it right here. It's a good thought. Good thought.
You know, it's right.
So kill that ugly IP default gateway command.
Kind of do whatever it takes within our ability to do it.
And go back to router OSPF default information originate. Oh. Okay, back to normal. Okay, I think we're okay for that. Let's see what we want to do here. Task 1, we're going to peer up with our provider. We've purchased a 1 gigabit Metro Ethernet link to Uncle Hump's ISP. So I've started at ISP, you're going to peer up with me. you need to form a BGP peer with my R1. Your ASN is going to be 100, which would never happen in real life. We're just using 100 for educational purposes. And Uncle Hump's ASN is 666. And someone actually has ASN 666. If you look it up, I believe it is quite possibly could be a DoD network. I'm not exactly sure about that, but I think it is. So the first thing we want to do is we just want to make sure we can ping from R3 to R1, and we've already determined that we can. The reason we want to do that is we just want to make sure we have basic connectivity. Now we're going to form a peer with R1 using the direct IP. So really easy to do that. And so first we're going to pretend to be the customer, and then we're going to pretend to be the ISP. So we're going to be peering up from here to here. And you're about to see how anal BGP is. So I'm going to go conft router BGP question mark, and this autonomous system number is going to be your autonomous system number. So the way I taught it last time was you probably want to have Notepad up, and then put in there us versus them. Okay, so us, we are ASN 100. Our IP is 10.10.13.3. Them, they are ASN 666, and their IP is 10.10.13.1. So just having this keeps everything kind of like in order so you don't mess up. And trust me, when you're tired, you will mess up. It's a guaranteed fact. Okay, we're just going to have this off to the side somewhere. It's kind of like there. So us, we are BGP 100. We're neighboring up with them, which is 10.10.13.1. Then when you do a question mark, you'll see that you've got a whole bunch of options. But to specify the autonomous system number, it's going to be remote AS. And it's going to be their AS, which is 666. Now you could do a question mark after that, and look at this. Got some stuff. You can hit enter right there, but you also have a couple things. Shutdown is one interesting thing. Shutdown lets you just passively shut down, not passively, but lets you shut down everything without having to type no and kill all the settings. Another way you could use shutdown is you could pre-type in a bunch of settings, so 5 lines of config, keep the shutdown in front of it, and then what you could do is you could do the no shutdown for that neighbor and have everything come up in one shot. But for here, we're going to hit enter. And after you hit enter, you could show Ip Bgp Summary. And you'll see that you're just kind of sitting there in the idle mode. Now, if you do a debug TCP or debug IP, debug IP TCP transactions, let's see what stuff comes by. Now the hello timers on BGP are pretty low. They are every 60 seconds generally. Very, very slow compared to OSPF or EIGRP. So here we got some stuff here. You'll see that 10.10.13.3, that's us. So we're trying to talk. We're on port 47484. We're trying to get to 10.10.13.1, port 179. Everything's closed, 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 and then finally we got a reset, and now we have been destroyed. So that's been toast. And then we try again and try again and try again.
gather, backgrounds of those texts and use those accordingly.
So R3, we've done everything on R3 side. Reason nothing's coming up is R1 has not been set up. So we're going to go over to R1. So now we're pretending to be the ISP. And just to refresh our memory, let's take a look at R1. We are ASN 666 and 10.10.13.1. So it's conf t router BGP 666, neighbor 10.10.13.3, which is the other side, and their remote AS is 100. Hit enter right there, go quickly over to R3, hit enter a couple times, and let's see what happens. Okay, so now you can see some interesting stuff happened. We start talking to each other, and then the word you're looking for is ESTAB, established, short for established. Then everything comes up, and then you'll see the magic words, neighbor is up.
Or this guy does it all, so I need just assign this.
Okay, after the neighbor is up, you can just verify things by show Ip Bgp Summary. And you can see right here, that's our neighbor. That's our autonomous system number, or that's the neighbor, and that's their autonomous system number. We've received a couple messages, not that many, and we don't have any prefixes. We'll fix that in about 45 minutes or so. You could show Ip Bgp, and that's not going to be that much. It's not going to be that interesting. Let's see. Show Ip Bgp question mark. Let's do neighbors. Okay, this gives you a whole mess of stuff that you may or may not want. Let's see, their router ID is all ones. How long it's been up for, nothing too interesting.
Oh, okay. So it'll be like a blended
So you can see on your side, you're 13.3, and the port you're using to connect to them is 61.921. Their port is going to be 179, which is the BGP port.
All right. Well, I mean, everything so far sounds okay to me. I think.
So as far as basic BGP peering, direct peering, you're just going from side to side. Any questions about that should not be that difficult.
There will be a timeline included in everything, and we're looking.
So how many of you think every 60 seconds hello timers and keep alives is pretty long? Anyone want to change this? Oh, let's change it anyways. Let's go on R3 and R1. After that, we'll go into router BGP 100. Going to do another neighbor statement going towards 10.10.13.1. BGP scan time 5, yes. So let's see what we can do here. Hey, look at this. Per neighbor timer. So you can set timers per neighbor. So let's see what we could do here. Timers. Look at that. Keep alive interval. 1. And hold time 3.
Places,
Let's do that.
and go, oh my god,
And it gives me a warning, hold time less than 20 seconds increases the chance of pure flapping. No, you think? Yeah. So let's end out of there. Show IP BGP Summary. So far, nothing, but the BGP timers is kind of interesting. Because as you can see, nothing's happening. But let's go over to R1. Let's change the timers on this side. So you can actually hit the up arrow to get back that neighbor statement. And just pop in timers 1, 3. Gives us a screaming chance, but screaming warning there. Now if we debug IP, let me think about this before I do this. Yeah, okay, we'll be okay. Debug IP packet. Let's see what we got here. Okay, so you can see debug IP packet not really doing anything too much. Okay, let's see here. Yeah. Okay, so nothing, not a big deal there. Expected a little bit more out of that, but no big deal. And let's just verify if we show IP BGP neighbor. Let's see what we got here. Keep alive interval is 1 second. Configured hold down time is 3. Yeah, okay. No biggie. Let's see what other tasks we have to do. We formed a peer. We checked the status. That's good. Oh, knowing what the BGP state means. We show IP BGP summary. This command right here, show IP BGP summary, that's probably going to be 80% of your commands in your lifetime for BGP. Just your boss will say, hey, is the BGP neighbor up? This 0 right here tells you how many prefixes or how many prefixes if you're not receiving any prefixes. But as long as you see a 0 or a number there, you're good. Don't be scared about 0. Now if you see the words like active or idle, I've included in your notes down here. BGP Connection States. This is shamelessly ripped off from, I think, Cisco's website somewhere. And so you can check that. Active and idle, those are bad things. You don't want to see that. So you can see here right now nothing too exciting is happening. If I show IP route, it's going to be the same as everything else. We don't have a B. B is going to be for BGP. Nothing. B is for BGP. We don't have anything in there because we are not advertising any routes into BGP. So right now we're just concerned about getting neighbors to talk. And the reason we're so concerned about that is if you can't get neighbors to talk, then you're not going to be able to exchange any prefixes. So it's not going to matter. Okay, any questions before we take a couple minutes of break? Any questions at all? I think most of the people in this session today are actually attended the last one, so you guys are cheaters. You know everything already. All right, let's take a couple minutes break and be back in about 2 or 3 minutes. So restroom break, drink break, whatever, and we'll be back soon. Whoops, I forgot to hit the record button again. So we are now pairing up with the loopbacks. We've already killed the BGP neighbor statements, and we're going to redo them. We're going to be pairing up with neighbor 1111. So from R3 side, neighbor all ones to remote AS 666. So it's listening. Nothing, no magic is happening just yet. I'm going to hit the up arrow. We're going to add in this update source. We're going to say you are coming from loopback 0. Hit enter there. In this third command, we're going to pop in Ebgp Multi-Hop. And if you put a question mark there, you can hit enter, or you could pop in different numbers. And what this means is when we're pairing up between two different autonomous systems, so this is 66, well, our side is 100. Their ASN is all 6s. So when you're pairing up with different autonomous systems, so you're going from 100 to a different number, BGP packets are assumed to have a TTL of 1. So that's actually fine if you're going direct here. That's not a problem because it's only one hop away. But now we have a little interesting twist here because we're going loopback to loopback. This is actually 2 hops. So we're going to need to trick BGP a little bit and tell them to make these packets live a little bit longer. And so Ebgp Multi-Hop, now if you just hit enter right there, it's going to be 255, which is probably not the number you want. So we'll do Ebgp Multi-Hop. Let's do 3 right there. And that multi-hop command does not need to match on both sides. They can be different. So if we look at our command, show run pipe s BGP, you'll see that we've got 3 neighbor statements right there. Neighbor all ones, remote AS, neighbor all ones, Ebgp multi-hop, neighbor all ones, update source. Any questions on the company's side of things? All right, let's go over to the ISP, R1. We're still in BGP, or at least I am. And we're going to neighbor up with all 3s, remote AS 100. Just hit the up arrow, do your update source. You're coming from loopback 0, and hit the up arrow, Ebgp multi-hop. And just to prove to you that they can be different, we'll just use 5 on this one. We'll go over to R3, show Ip Bgp Summary. You'll see we're in active mode. Trying to peer up, trying to talk. Going to wait a little bit. And let's see here. I think I still have my debugs running. Yeah, I still have my debugs running. It's kind of interesting. Nothing's happening. Let's just make sure we have a route over there. Show up your route. Now on R1 side, if I try to ping all 3s, I don't have anything. So let's see if a default route solves this. Let's do IP route. Now I'm on the ISP side, so I'm going to make a default route going towards the company. This would be your company, so .3. Okay, so I should be able to ping all 3s now. Yep, we get a good ping. Still nothing's coming up. All right, so you see here I've got connectivity. I can get to all ones, right? My BGP neighbor is not coming up. It's still active mode. My BGP config looks correct. So BGP config on R3 looks correct. And going over to R1, that looks correct as well. Alright, so nothing too big of a deal there. So here's the problem. BGP is stupid. So if you show IP route, you'll see that the way we're getting there, if we actually show IP route 111, it'll say network not in table, which is fine. So network's not in table, we're going to use that default route right there. And so your destination for that neighbor statement cannot be with a default route. And you can see it right here. You've got a default route, it's not working. So let's try this. We're on R3, IP route. I want to get to all ones, and we'll do a, well, we'll match it exactly, right? Let's match exactly, and then our next top will be 10.10.13.1. Okay, so we got that. And let's wait a couple seconds. And looks like we've got a BGP adjacency is up. You can see right there, as soon as, well, not as soon as I put in that static route, but, you know, about 10 to 15 seconds after I popped that in, BGP caught up with the keep alive, sent one out, and they finally connected. So you can see right there, you need something better than a default route. Why? Because BGP is stupid. Also notice that one side can be a default route. That's fine, because it's actually, you can think of it as two servers trying to connect to each other. As long as one side connects, they can both talk to each other. So R3 talked to R1, and R1 said, cool. So you don't necessarily need to have specific routes on both sides, just as long as one side has a good route. Any questions about this? So where's the potential areas for screw up? Well, there's several. So all of this is a potential area for messing up. That is a potential area of messing up. The destination remote autonomous system and the wrong update source. Be careful about that. Also, your IP route statement. If it's default route, that could be a sign of something is wrong. And also just not having a route at all to get to the other side is obviously a screw up, a potential, well, not a potential screw up, that will be a screw up if you can't even ping the loopback that you're trying to reach. Okay, let's take a look at our tasks. So why is peering with the loopback preferred? Well, I kind of fudged it a little bit here. It's in the books, they like to peer to the loopback. In real life, it's kind of a 50-50. So it's kind of personal preference. Not personal preference, but your ISP will tell you the numbers. And actually, your ISP will probably just say, here's the IP, here's the ASN, you know, peer with us. And then for $250 an hour, you can enlist the help of a consultant that they prefer. Actually, I shouldn't say that. Usually, depending on your ISP, like if it's level 3, they're more than happy to help you out, even at 4 in the morning on a BGP failover test like I recently did. Might take you 16 minutes to get someone who knows how to redistribute, but that's a different story. Okay, why do you need a route to the loopback? Well, if you don't have a route to the loopback, definitely nothing's going to talk. And the extra commands you need, well, you need something better than a default route. All right, that is task 2. Just pairing up with the loopback. Okay, so Justin says he's still in an active state. Okay, let's figure it out. Go on R3. Show IP route all ones. And tell me what you got. Okay, in the chat window, Justin's got router BGP 100, that's fine. Neighbor all ones, remote AS all sixes, neighbor Bgp Multi-Hop, that's cool. Update source, loopback 0, that's good. No auto summary, that's fine. And so what about your show IP route all ones? How are you actually getting to that guy? Let's see, show IP route, you've got a static route. Okay, so as far as your side, you should be okay. Now let's take a look at the ISP side, which is R1. So if you show run pipe S router BGP, let's take a look at the stuff coming back to router 3. Let's see, router BGP 666, that's good. Neighbor 333, remote AS 100, that's good. Neighbor all threes, Ebgp Multi-Hop, that's good. Update source, loopback 0, that's good. That looks all good to me. Let's do this. Can you actually get to that next hop? Do a ping from R1, 10.10.13.3. Success. Okay, you can ping the next hop. This, show IP interface brief. Yeah, that might make it easier. Share your screen. And then also show IP interface brief on R3 as well.
What'd you say?
Show IP interface brief on R3. It's taking a long time for Google to catch up. Okay, that looks good. R1, loopback all zeros, that looks good. Show IP protocols on R1 and R3. Okay, that looks fine. And then hit space on R3. Yeah, looks good. Show run on R3. Okay, hang on for just a second here. Let's see. Link to service provider, they're all, you're doing /24s, that's good, 10.10.13.3. Your loopback is a /32, that's good. You've got your OSPF in there, you threw everything into OSPF. Default information originate always, okay, that's good. Yeah, it looks good to me. And hit space on R1. Yeah, you're good there. Hit space on R3. Okay, so you have a default route going to 10.10.13.1. Okay. Oh, do you have any static routes on R1?
No.
Okay, there you go.
I thought you said you only need it on one side, or did I get that confused with something else?
Well, yeah, you need a better than default route on one side, but if you don't have any route on R1 coming back, how's the traffic going to get back to R3? So what you could do here is this. Just look at my screen. So on R1, do a debug IP packet. And here's what we're going to do. I'm going to kill that static route. All right, so basically I'm going to look like you. Because what you have is you don't have a static route on R1 coming back. So now in R3, I'm going to ping 1111. Right? Now, this ping works because it's pinging from the fast Ethernet link. Now, if I do the same ping, but I say source loopback 0, it's going to die because the return traffic needs to hit 3.3.3.3. So this is kind of, just be careful when you ping because there's a difference here. So the difference is this. So in this case, I've got two loopbacks on router 3. When you do the ping, you're pinging and you're saying, I am shooting it from fast 00. The default route gets me here, that's not a problem. And R1 can see this side, no problem. So 10.10.13.1, no problem. Now when you ping with the source of here, what happens is the ping does reach R1, and the ping does reach this loopback, but on the way back, R1 just dumps it because R1 has no clue how to get to all threes. I'm not going to write that out. So it doesn't know how to get to that loopback. So we need a route on R1 to get back. So that's where your default route comes into play. And so if we look over here, you'll see that I'm trying to get to all ones, or trying to go from all ones to all threes, and it says it's unroutable, so I don't know how to get there. So I change that, get my default route back, and then I should be good. That's pretty good troubleshooting.
So am I doing a IP route to the 3 network or just a default?
Just chuck everything back. So all zeros, 10.10.13.1, or 10.10.13.3. Yeah. So I keep getting that mixed up. So send everything back this way. Because you can get traffic going left. You need some way of getting back. All right, so we're making pretty good time. Yeah, we are. So we're going to end with task 3. So if we have time, we're going to advertise some networks into BGP. So right now we're paired up, but it's not that exciting because we're not actually learning anything through BGP. And we could verify that with show IP BGP. We got nothing. So there's two main ways of popping networks into BGP. And the reason R3 would want networks going into BGP is right now you could kind of think of R1 and R3. They're talking in this BGP language right here. Now R3 is running OSPF in blue on its side. So it's doing OSPF over here. And so what we could do is we could redistribute OSPF into BGP. We could take all these OSPF routes that we know and kind of translate them into that side. And once we throw it into BGP, the rest of the internet will know about it and potentially be able to hit our servers and stuff. So just pretend for a bit that these 10 networks are routable, because I know normally they're not. But we'll pretend that for now, these 10 networks can hit the rest of the world. And so before we do this, let's go to R1 and do a U-all just to stop those debugs. And we'll do a debug IP routing just so we see what's going in the routing table. And let's just show IP route just to see what we got. All we have is a static route, so no big deal. We'll go over to R3. So if we show IP route over here, we'll see that we have a bunch of O routes. We've got just a whole mess of routes. So I've got, let's see, there's 4 there, there's 9, so there's 11, oh, I missed one. So there's 12 OSPF routes in our routing table. So theoretically, I should be able to pop these into BGP and send all of them to my neighbor, who will in turn tell the whole internet how to get to us. So we want to advertise prefixes into BGP so that the rest of the world knows about our networks. So we shoot networks out, shoot the prefixes out so that traffic can come in. So let's do that. Let's go into router BGP 100, redistribute OSPF 1. And we could add some other stuff in there. We could put metrics, we could do a route map, we could specify a VRF, we could match external, internal. But for now, we'll just throw everything into BGP. Hit enter. And R1, you can see R1 just went nuts and added a bunch of stuff. And so let's see, if I show IP BGP, you'll see that I've got a bunch of stuff in there. Alright, so let's see what we got here. We've got that all 3s, all 4s. So basically it told us about all the loopbacks. Okay. Show IP BGP. Okay, so now we wait a little bit and now you see that we've got this star and caret, which means we can actually get there. Ooh, routing loops, cool. And you'll see a deletion, so it looks like I have some route flapping with this. That's pretty cool. Okay. So let's see, on yours, you'll probably see one that's an R in front of there. So instead of a star, you'll see an R. You can turn off the debugging with U-all. So R means a rib failure. Reason that's a rib failure is, well, if we look at our topology here, that's the link right there. So R3 is trying to tell us about this link through BGP, and R1 goes, okay, I see it, but I'm not going to use it. And why do you think R1 is not actually going to use it for routing? Rib failure means I'm not going to put it in my routing table. So how do we already know about this guy? Lower AD, yep, and because that is a connected route. So you see that if we go to R1 and we show IP route, see that 10.10.13.0 is directly connected. So rib failure is not necessarily bad. It just means that, hey, someone else won on that. And I would certainly hope that directly connected wins over BGP. Now all these other guys, they're in there. And I can reach them, or let's see if we can reach them. Let's ping 7777, and we have a success. Right? And the reason I have a success is because I've got this default route just chucking everything to the right. If we show IP BGP again, you'll see this path right here. This path means that this question mark says, well, probably it was redistributed on the other side. And it came from AS100. And now it's hit us. As these networks, as these prefixes go through other autonomous systems, you'll see like you'll have this long path, like it goes through 100, then 200, and 150, and it'll go, as it makes its journey through the internet, you'll see a bunch of paths in front of there. And the reason for this is if it sees itself in the path, so if for some reason you get a network flying in, and let's say for some wacky reason we have a point-to-point link that goes from R7 to R2. For whatever reason, right? And so in blue, this is going to be AS666. In orange, this is going to be AS100. So if for some weird, wacky reason, information about this network, 666, happened to flow through the long way and come back around, well, what's going to happen is R1's going to get that packet, that prefix. It's going to look through the path and say, whoa, there's a 666 in here, so we have a loop. We have a BGP loop, and I'm going to kill it. I'm not going to accept that prefix. You can force BGP, you could do a lot of things and you could force it, but in this case, normal behavior is you're going to kill it. Right? So any questions about the redistribution? This is really, really simple, just chucking all of our OSPF routes in there. And let's see what we do over here on R3. Actually, let's go to R1. Okay, we got a question. You would kill another way to get in to another AS. You would kill another way to get into another AS. I think R7 to R2 is one way, R3 to R1 is another. Yeah, so if for some reason we did have multiple links here, something like that, this is good, not a problem, because we don't see ourselves. But if for some reason it loops around, we're basically saying I don't want to take this way. Now you could be really jacked up and go, okay, well, let's run OSPF and BGP over that link. Then you may have some other traffic that's not related. But as far as BGP is concerned, yeah, it's not going to like that extra link. And this type of thing is very easy to simulate. What you want to do with your topology when you have free time, just shut it down. You'll probably have to add, no, you won't have to add another card. Just go, this is going to be fast01, fast01, make a link, peer them up, and see what happens. You'll peer up just fine. That's not the problem. It's just when you do the prefixes, when you pop them in there, just notice how the show IP BGP tables differ on the different routers. And I can do that as a YouTube video or for next time. The routes that originated from your AS going that particular way will be ignored. Yeah, so we have to be careful in seeing which way they're coming in from. Okay, now R1, if we just do a quick show run, you'll see that under our BGP statements, we just have a neighbor statement, nothing too exciting. We're not telling R3 anything, and that's really because we don't need to, because we've got default routes going everywhere, and we have connectivity. Now R3's perspective, show IP BGP. This is your company. These are the networks in BGP, but remember, this is stuff that we're taking from OSPF and popping into BGP. So far, we don't have anything from the quote-unquote internet. So another way we can put a prefix into BGP is we could statically define it. And if we, let's say we try to be slick here. Let's go into router BGP 666. And the way we statically define it is with the network statement. And watch what happens here. Let's say we want to advertise 66.66.66.0. Right. We're going to have to type in the word mask, and we're going to say that's a /24. Okay, so I'm going to see if this statement works. Network 66.66.66, mask /24. We'll hit enter there. And if you show IP BGP, you'll see that I don't have it in my BGP table, even though I typed it in. And so the reason for this is very simple. In BGP, if you want to advertise a network, if you want to throw a prefix into BGP, you need to already know about it through some means. And in this case right here, I'm going to just statically define that route. And it's very easy. I'm going to do IP route. So I'm going to do IP route, make that a /24 mask, and I'll just do null 0. And so now if I show IP BGP, you could see that I've got that route in there, or that prefix in there into BGP. And so now what happens is R1 should fling that BGP prefix, whoa, You'll fling it over to R3, and R3 will know about it. So let's see, let's go over to R3, show IP BGP, and we do have a prefix right there, all 66s. It's a /24, next hop all ones. And it says it's coming from AS number 666. And you can see here, here's kind of interesting. Before we saw the I with redistribute, here we're seeing an I, or that we saw a question mark before with redistribute. Now we're seeing an I, which means that was a statically configured BGP route. So you could either type it in or redistribute. There's actually many other ways you could pop routes into BGP, but those are the two main ones. Any questions about this so far before we go into extra credit mode? So redistribute, very easy, just redistribute, chuck everything in there. The network statement, the only gotcha there is you have to make sure you have the network before you type it in. So network 66, 66, 66, we didn't have that route in there, and we actually had to do the route, and finally it popped in our BGP table. All right, extra credit mode. Let's do this. Let's go to R1, go into BGP, and get back our neighbor statement. So we're neighboring up 3333, and do a question mark after that. Now, in real life, when you're going to peer up with BGP, you're not just going to be given some IP addresses. In real life, they're going to want a password 100% of the time. If you're peering up with a good, with a big provider, Cogent, level 3, big guys, needs to be a password. Because you're dealing with the internet here. We don't want to just let everyone peer up with us. So if I type in neighbor 3333 password, and we'll say password 7, let's say. And then we type in the password, let's say Cisco. Oh. Password Cisco, show run. So you see right there, neighbor all threes, password Cisco. And what we're going to do here is we're going to go to R3. Let's shut one side down. And we talked about that before. Router BGP 100, neighbor 1111. And let's do the shutdown command. And so the shutdown command, our neighbors are down, show Ip Bgp Summary. And this is kind of interesting. Instead of just saying idle, it's saying administratively idle. So it's kind of like at administratively down. So it's idle because you typed it in. And just to show you how it looks on the show run, let's go over here. And right here you'll see that it's neighbor all ones and shutdown. So to cancel that out, pretty easy. Just go back into BGP. Neighbor all ones, remote AS 666. Oh, still shut down, so we'll pop a no in front of there. Show run again. Let's see if that's gone. And now if we show Ip Bgp Summary, you'll see that we are idle. It's kind of interesting. So now let's pop in our password. Let's see if we can get this router back up. Neighbor, all ones, password, Cisco. And pretty much as soon as I type that in, everything looks good. Let's see, they're talking. Oh, active. They're going to try to talk to each other. And let's show run just to make sure we're good here. Got neighbor 1111, remote AS666, password Cisco, so we should be good there. Show Ip Bgp Summary, and we're back up with a prefix of 1. So password of Cisco on both sides, and they finally connected. All right, that was BGP peering and a little bit of putting on networks and redistribution into BGP. In our next class, we'll be doing more about putting networks in there and messing around with next top self and a couple other commands, getting things to work. But should be a very good intro into BGP. And in 2 classes later, we'll be manipulating BGP metrics and attributes to get routes to go different ways. Right, everyone, thanks for watching. And if you want, you can save your configs. Just go up to this icon right here, click on it, and extract to a directory, and just find a directory you want to save your configs to.